We are summer group 7 and we had the power washer Roomba. So our project background, our goal was to build an autonomous robot capable of power washing driveways, provide a method of cleaning large areas of concrete with minimal staff, provide a method to clean for people who can't necessarily do it themselves. So we wanted to make this robot so possibly zoos or um, Disney amusement parks could be able to set this robot down and kind of just clean a large area overnight, or landscaping companies could set it down on a driveway, let it run, and while they take care of the hedges, pull weeds, mow the lawn, etc. Some of our design requirements, we wanted to make sure it was waterproof, as it the for the batteries and control module in order to not short circuit anything. The pressure washing module and hoses must be able to handle the minimum PSI of the power washing unit, which it was able to do. We wanted to be able to drive over small obstacles. The hose attachment must fit standard hoses. Overall water usage, we wanted to be less than or equal to current market power washers, which since we used a market power washer, it was equal to um, current market power washers. We wanted it to be programmable and follow a route and turn on and off at the proper times during the route. We want it to be automated, cheaper to use, and higher in person, and effectively cleans the desired area, not leaving any dirt marks or incomplete circles. Some of our successes and failures. Some of our successes, we were able to waterproof the batteries and control module in a Pelican case, and that sat on top of the main frame, kind of away from the hose and the cleaning device. And then the hose attachment was able to fit as it was a current market power washer that we just attached to our frame. So everything in terms of power washing and pressure washing module, um, we achieved in that sense. And it was programmable as we got it to program and we got it to rely on human input in order to move from point to point. But our failure was it was not fully automated in terms of LiDAR enabled, and you could just set it down and it would not run into a house, fall off a curb, etc. And since you do have to have a person controlling it, it turns out it was not cheaper as you would still have to hire the person to control the pressure washer um, Roomba itself. And then it did not achieve our incredibly high safety factor as the motor mounts that attach our motors to our frame, which in turn attach the wheels to the frame, um, were relatively weak as that was an area we did not anticipate for our frame and everything to be so heavy that it would break those and cause us to fail there. Some of our difficulties were with our coding and electronics as we were all mechanical engineers. None of us really had experience with coding or electronics, so we had to figure that out all on our own. And coding definitely took the longest amount of time, as it took about 3 of the 5 months we had to work on the project. And electronics took us about another month to figure out amongst ourselves as well. And then we kind of set out greater goals than we were able to achieve. If our realistic goals were to just create a remote controlled pressure washer, we would have been able to achieve that. And then some of our difficulties were with scheduling conflicts, time management. We definitely did not build in enough time for prototyping, which was the main area we failed at. Was we did not have time to work out all the bugs. So going back, we definitely could have built in more time for prototyping than we did. And with 3 of us working jobs and doing school, and one of us having 19 credit hours, we had a lot of scheduling conflicts with ourselves. And then technical issues we will talk in a little bit later in the presentation. Some of our project designs, we initially started off with design one, which was basically just building our entire thing around the surface cleaner of the pressure washer. Design two, it's kind of having the pressure washer unit off to the side of our unit. And then design three, which was our main goal, was to have the surface cleaner underneath everything, have a sheet metal layer over it to protect everything from waterproofing, and kind of just have it drive around that. Now, when we went into our designs, we aimed for number three, but as we started to build everything, we actually ended up with design 2. So we wanted this to be our main design here at the end. This was design 3. Was our goal at the beginning of the semester, or the beginning of the project. We wanted to go for this, but we were not able to achieve this design, as when we actually started to build it, we ran into a number of issues with attaching it to the pressure washer and attaching it to the frame itself. So this was our before designed robot. It was mainly just skid steering with the regular wheels, so it wasn't very functional, and it only moved relatively in a straight line. It wasn't able to turn left or right for the most part. And then this was our final design. As you can see, it was like design 2, where our pressure washer surface cleaner was off to the front of the unit, and that's how it would clean. And then we changed our wheels, and then we upgraded the frame to make it more durable, and we had our waterproofing Pelican case and the pressure washer unit all attached to it. So our electronics, we used a Raspberry Pi 4B as our CPU, and then that would send electronic signals to our Arduinos, which were our motor controllers, and those would send signals to the motor to turn on and off, and then we were able to waterproof all of this, and it was able to all run off of one battery bank. And then the front wheels had operated off of one power supply unit, and the back wheels operated off a second. We used Mecanum wheels, which allowed for omnidirectional travel by changing wheel direction based on direction of rollers. And it has specific left and right wheels, so we had to make sure we had our left wheels on our left side and our right wheels on our right side, as when we would drive in a different direction, it would not function the way that wheels were designed. So there's a chart here, as you can see. If we want all the wheels to go in one direction, we just tell them to go in all one direction. If we want to go straight to the right, we have the left side wheels go in opposite directions, and the right side wheels go in towards each other. And then if we wanted to go left, it would just be the inverse of that, same with forwards and backwards. Motors. We used power seat motors, as they were a high torque at low RPM, and they had a worm gear with a shaft attached to it, and they were relatively cheap and kept us within our budget. And they were able to run on 12 volts and at no load used 1.5 amps and had a stall rating of 17 amps, which is well within our battery module and power supply units capabilities. And then we had our sheared moment diagrams, and then we did a Morse circle on our frame to make sure it could withstand all of our weight that we were putting on top of it. Coding. Some successes were inputs from a human to move the robot, and it can move in 4 directions, and was programmed to move on its own. It was not LiDAR enabled, and it was not independent without human setup, and we'll talk about more on some of our pitfalls in the second part of this video. Then our prototype phasing, the motors, the wheels moved along the shaft of the motors, which as they got closer ran into our motor mounts, so we didn't have time to build into it. And then our frame was too heavy for the wheels and motor mounts, as it caused too much drag onto the wheels, and it was not able to move very far very quickly. And then the Arduino's wiring class broke, so we were unable to apply power. And then here's some more pictures of just us prototyping, and then here is a short video of how we actually got it to move. As you can see, that the front right wheel there did break, so this was us actually prototyping it, but then we'll go into our second part of the video talking about why things failed. Alright, so some things that went wrong were in our Arduinos, the screws ended up getting stripped, so we weren't able to wire the back motors on either side due to them not being able to transmit power to each other. So that was one of the things that went wrong, and that was our root cause. Ways that we could fix it is buying a new Arduino, putting it in there, and then rewiring it, and not hopefully having to do as many changes with the wire.
Also, we ran into the issue with our wheel mounts that this set screw right here was not strong enough. So it caused just the motor to be spinning and the wheel would stay in place. But what it caused with the threads on this hub here, the set screw would just push itself in, causing the wheel to get stuck on this lip of the motor mount right here. So we would want to redesign the mounts for the wheels.
Another error that we ran into was the frame itself being too heavy for our motor mount as well. So we had to install caster wheels on the bottom in the middle of the frame to help support our motor mounts on the ends.
We also got way too small of a pressure washer disc. That was mostly down to budgetary constraints. If we had a bigger budget, we could have gotten a significantly larger disc, probably in the order of 30-inch.
And finally, we realized that it might not have enough force to drag along a long hose, and we're kind of limited on the size. If we wanted to put a tank on it, it'd be very heavy, which kind of runs into the same issue. The way we could solve that is a combination of making the frame better, these wheel mounts, and basically every other upgrade we've had to do.